Hi, it's Tim, and today I'll be running through a little bit of Lab 6 and showing you how to edit PWL files and also how the ideal versus the bouncy switch works. Okay, so for Lab 6, I'm not going to re-go through how to build the circuit. So here we've got our D flip-flops and we've got our XORs as usual, so you should be able to wire those up. But I will show you just what this bouncy trigger entails. So we'll put our bouncy switch here, which simulates our physical switch. And I'll also put an ideal switch next to it. Okay, and I'm just going to wire these up to an input voltage. I'll just use the same PWL file as last time. Okay, and I'm just going to set up my voltage sources as normal, so 5 volts here. And this one, I'll go to advanced. I'm going to load in our PWL file from last lab. Okay, so you can see it finished the simulation here. I'm just going to plot these two. And as always, I'm going to change this to an easier to view color. And I'm going to add a small offset. Okay, and now I'm just going to zoom in to one of these transitions. Okay, so you can see our V ideal goes straight from 5 volts to 0, whereas our bouncy actually has these jutters, and this actually mimics when you physically press a button down. It won't instantly contact it. It might contact once and then be not in contact and then contact again. So what we want you to do is to build an RC debouncing circuit. Okay, so this goes through here. So for here we can just draft. So we've got our resistor here and our capacitor up here. Okay, and we can edit those sources by left clicking on them. So we want you to debounce the circuit and then pass them through these Schmitt triggers, which will help us to get back to our 5 and 0 voltage levels. And then what we want you to do is to pass it through this state machine. Okay, and that will actually need you to edit both the clock and the input sequence. So you have to ask yourself, do I want them to be transitioning at the same time or at different times for this input? So I'm just going to show you now. I'll go into this file. I'm just going to show you how to edit it. So I'll just open it with my text editor. So let's say we want to add a new timestamp. So I'll just copy these, paste them, change that to 800 milliseconds and 801. And the voltages should be always, so here I'm going from 5 to 0. And this is another transition from 0 to 5. I'll save this, okay, and you'll see if I run this again. I'll just plot the input here. And you can see from 7 to 800 microseconds, we have this new 5 volt signal. Okay, so hopefully that showed you how to modify this to be as you like. And I'll just show you what happens if you don't. So let's say we just put this one in as, let's say 900 milliseconds. We want to go down to 0 volts. Okay, so we'll save this. We'll run this again. I'm going to plot this. And we can see from that 5 to 0, we actually get this diagonal line. So that's why we want those 1 nanosecond transitions. Okay, just as a recap, today we went through how to edit our PWL files and also what the ideal versus the bouncy switch looked like. I hope that helped, and I'll see you in the next one. Bye.